I'm Richard with EV4U Custom Conversions, and welcome to another episode featuring our VW transporter. We're going to take off where we left off last time and show you what's come together in the engine bay. Let's take a close-up look. So we've got the controller in place. It's not mounted yet really, it's just sitting there in place. Just for fitment purposes, kind of get a feel for it in the three-dimensional form here. It's mounted at the top here. That is not going to be all. We need to mount along the bottom so that we don't have any movement. Again, this isn't tight on there right now, but anyway, mounting across the top would not be sufficient, so it will be secured across the bottom also. We also have to hook up our plumbing on the back side of our chill plate here. We can see that coming from our main contactor over here to the controller with our power, nice short run. Then of course we'll run from here down to the motor. What we're going to focus on in this episode is the 12-volt wiring. And a lot of that's going to go on this piece right here, which is going to fit right beside the controller. And so that'll be mounted in that area, and our throttle's right here. So we haven't developed our throttle setup yet, but we have the clearance for it, and all of our 12-volt stuff, or the bulk of it's all going to be on one board here. And so we're going to show you how that is done, how we lay that out and prepare the components for mounting, and then how we wire it up. So for that, let's go to another bay and we'll show you how we do that. Okay, what we have here is a shot of the computer monitor. So it's not the best video shot, but what we're looking at is our board that we're going to use for mounting the components on. And so we're going to have our there's going to be 3 relays here, single pole, single throw relays. There's another one, single pole, single throw, that is the key switch relay for the Curtis. Here's going to be a single fuse that we're using for the power brake vacuum pump. Here's our fuse block, our diode mount, terminal mount, and 2 terminal strips which feature 8 connections each. And so what we've done is we've laid out everything the way that we want it on the board, and then we have all the holes for mounting and for where our wires will pass through. And so we're not going to drill those all the way through. We're just going to do a pilot hole, so that if we choose not to put a wire right here, we don't have to have the hole. We'll drill that by hand, but we'll have everything marked where it goes. So we're able to do that on the computer, and so it makes for a nice clean layout. We get to see it ahead of time and manipulate things the way that we want. So let's show you that being done. So don't know how well it shows up, but basically what we've done, we removed all the text and the boxes for the relays and that kind of thing, and we're left with nothing but the holes, and we're going to select those to cut. Kind of doing it in a random pattern. It's kind of based on where we copied and you know, part of the process of how we developed the template. So it's not doing it in the most efficient manner. Now you could do this with a ruler and a pencil. But we save all this so that we can do similar ones, so forth, and it is actually a much faster process if you have the capability to do that, of course. But as with most things, there's more than one way to skin a cat. This is just the method that we use. And so let's fast forward and show you what it looks like once it's completed. Well, here's a shot of the component board with our components on it. We've got the 4 relays, our fuse block, a fuse, diode, terminal, and terminal strips. So next, we'll wire the thing up. And what we're going to do is we're going to wire those items that will go from the terminal strips to the items on the board. And the items that are off the board are wired last. So what we did, in order to mount this on our spot here next to the controller, we drilled and tapped a couple holes. This is 1/4 inch thick aluminum right there that we're mounting to, and so the controller is through bolted with nylon stop nuts. The whole thing is going to be then have a base piece that will go below here. There'll be a piece of ABS that goes below the controller, just to make sure we keep any splash away from the connection point here. Here's where our wiring loom connects. And like I said, we still have to come up with a throttle mounting setup. So that's where we are now. Next we'll do the onboard wiring of our component board. So that's what we'll show you next. Here's a shot of our chill plate before it gets installed. We got the plumbing on the back side here. It's going to go like this in the vehicle. We have a clearance issue on the bottom, so that's why we went with the 90. So let's go ahead and install that now. Here's the controller mounted in place with the cooling lines connected. We still have to do the cooling setup itself, the pump, the radiator, the fans. That has yet to be done. And then next to the controller is the DC board. We've just started wiring it, as you can see. So there's a lot to be done still. The throttle, our lower mount that goes across for the controller and the DC board. A lot of wires still hanging, waiting to be attached. But here we are at our main contactor. It goes to the positive side of the controller, and our negative line out of the controller. The 3 phases coming AC out of the controller, and we covered the thing with the black there. This looks a little bit better. It was kind of a tight fit with the heat shrink that we had, but we got it. So we will continue to wire things up. We're still waiting our DC to DC converter. We still have to do the power steering. So that's going to be coming up here pretty soon. We'll be kind of waiting because it's going to take up some room. And so we'll be doing the cooling system for the controller, the throttle, hooking up some of the remaining lines to the main contactor here. And of course the vacuum brakes, get those set up. Our cooler is going to go underneath there up front near the transaxle, I think. There's an unknown still. All we have are photos, or a photo of what the cable shifting mechanism looks like, and so that will be installed when it comes in. We don't know when that'll be. It's coming from England, and hopefully it'll not take up too much room here. So we don't know how that's going to run yet, so that's kind of making us hold back on where we mount anything else in that vicinity. Kind of a close-up of our DC board. Here's our unswitched 12 volts coming in. Coming into this point will be switched 12 volts from an ignition source. This is our power relay, which is going to take that ignition source and switch power to our fuse block, as well as our power steering and power brake relays. This is the key switch relay, which will send pack voltage to our controller. It goes through a 10 amp fuse. This is a fuse that's going to go goes between our relay and our vacuum pump, 30 amp. So a lot left to be wired, but it's coming together. Stay with us. Alright, another update on our transporter project. My assistant today is Oscar.
Hi.
And so what we've done today is we've hooked up the electrical for the power brakes. We showed you the plumbing part of it before, the vacuum hookup. So today we did the electrical. So let's kind of follow what we've done to do that. And then we'll turn on the key and make sure it all works. Because that's what's supposed to happen. Whenever you turn on the ignition, if there's not sufficient vacuum in the system, the vacuum pump will turn on, bring it to that point, and then shut off. When it drops back down, it comes back on. So let's see how we wired it up and see if it works.
So to energize the vacuum pump, we need to turn on the key? and our power will go to the vacuum pump relay, through the coil, and to the vacuum switch, and to the ground. And the vacuum switch will energize the contacts in the vacuum relay, and sending power through the fuse back to our vacuum pump and to the ground, and that should turn on the vacuum pump.
Alright, so why don't we turn on the key, Oscar, and see what happens. So here's a shot of the vacuum gauge on top of our vacuum reservoir, which is sitting here next to the pump. So okay, Oscar, turn on the ignition. Our pump's on. Very quiet. You almost can't hear it. Leaning on the vehicle, I can feel just the slightest vibration. There we are at 15 inches of vacuum. We're going up. It should cut off about 18. There you have it. Right about there. Here's the relay. She shut off. Go ahead and hit the brakes a couple times, Oscar. Boom. Drops down to 12. It comes back on. And then she's building back up. So there you have it. Very simple circuit. So that was our power brake relay and fuse. So we'll tuck up the wires later, but that was a great job by my assistant, Oscar. Well, Oscar, what do you got there?
Well, I have here the emergency stop button, which is installed on the dashboard, which will go just in front of the shifter and below the stereo.
All right.
We have here the back side of the switch, which has the ignition wire coming off and sending it through our contacts in the back. And the other side has for our other components that will turn off the circuit in case of an emergency.
Okay, so what we're doing is we're coming from an ignition source through our emergency stop button, which then goes through our safety interlock relay, which is in the battery compartment. It goes through the safety interlock relay to the inertia switch that Oscar installed up in the back corner here, which is on the solid part of the body of the vehicle, so it'll be activated in an accident and yet easy to reset. And it goes from there back to our component board and connects to our key switch relay. So bottom line is, if the vehicle's in an accident, it's disabled. If it's plugged in, it's disabled. Or if someone were to activate the emergency stop, it's disabled. And all of that disables the key switch relay, which is the far left one there, which basically deactivates the controller. So stay with us. More to come. I know this is supposed to be a video about the transporter project, but just wanted to share with you another little project that just came up. On the way to work this morning, the Carmen Ghia gave a little shudder and lost power. So I coasted to a stop, and the controller wasn't making its usual low throttle whine, so I assumed that the controller had given up the ghost. And so made a phone call
got my truck, the tow bar, and towed the Karmann Ghia back to the shop. Well, at the shop we did quick little testing, and indeed it looks like our Curtis 1231C 500 amp air-cooled controller finally had been abused enough. This car weighs 2,200 pounds and is typically run in hilly terrain, up and down, at 70 plus miles an hour in 100 plus degree weather. Yesterday, for instance, we were running up a grade for quite a few miles, 6% grade, with 2 people in the vehicle, a windy road, so we were going rather slow, but 106 degrees out, and so the Curtis was running hot. And we added, a few months ago, if you've been following our videos, we added a chill plate on the back side of our heatsink to help cool a little bit more. It's not ideal, it's not making direct contact to the controller itself, but we didn't want to have to redo everything. It was just an add-on, and indeed it made a great improvement. We're able to do our normal run into town and back, about a 25-mile loop. 20 plus miles of that is freeway, up and down, and then part of it's in town, which is mostly level, or fairly level. And this time of year, 100 plus degree temperature, making 20 miles to 25 miles, mostly freeway. Sometimes that last mile or so, it'd go into thermal cutback. And really didn't affect things at that point as far as the drivability, but it's not where you want to be. You don't want that controller working that hard all the time. And so just in our normal driving routine, we push the Curtis to the limits. The reason we chose the Curtis originally for this vehicle was to display and show the commuter package, which is our most popular package, and it features the Curtis controller and either a Warp 9 or the Impulse 9 motor, and so that's why we chose it. So what we're going to do now, since we now have the opportunity to make a change, is we're going to go to the Evnetics Soliton Junior, which is perfect for this vehicle. We could go to the Soliton 1, which is a 1,000 amp controller, and really give her some performance. But this is a commuter vehicle. It's not a race car. It handles like a race car, got great handling. But bottom line is it's still a commuter vehicle, and we want to continue to show the commuter vehicle components and properties. And so one of the things that we offer with the commuter package as an option is the upgrade to the Soliton Junior. So we're now going to do the upgrade, and we'll get a comparison after putting just over 17,000 miles on the vehicle with the Curtis controller. We're now going to be able to see how the Soliton Junior does on the exact same vehicle. So stay tuned for that information and for that transformation. We don't happen to have a Soliton Junior in stock, so we ordered that, have it on its way. We already have our liquid cooling in place, so that'll be an easy transition to go from the Curtis to the Soliton. What we are going to have to do is change our component board. So what we'll do is we'll remove this entire board, and we did that before. We showed you in a previous video when we added the chill plate on the back. So we'll remove our throttle connection, We'll remove our lower wires on the terminal strip there. I believe there's 8 of them. And a few other wires here. 5 bolts, and this whole component heatsink comes out. Once that's removed, we'll be able to make a new one. We will have, the new one will feature the Soliton Junior mounting on it. We won't have a main contactor out here, as the main contactor is internal to the Soliton controller. We'll be using a different throttle control. And so there will be, some changes here. We will still need to have our shunt mounted back here. We will continue to have all the 12-volt and peripheral wiring. We will have our cooling reservoir still in place. And so it just will be some subtle changes. It will actually look a little simpler probably on here. So stay tuned for the new look and the improved Karmann Ghia. Like I said, this is the base model commuter package. Works great for areas where you have level terrain and moderate demands. But we demand a lot more out of our car. We drive it hard. It averages about 50 miles a day, up and down, interstate speeds or better. And so, we're pushing the lighter weight components. So anyway, that's the latest on the 1974 Karmann Ghia. And so stay tuned for more on that, as well as our Volkswagen double cab transporter. As always, thanks for watching.